Hi everyone! Let's go over some homework questions from lesson U1A3 where we learn how to graph polynomial functions from a factored form. In question number 1a, we are told that there is some polynomial function of degree 3. It has a double root at 4 and a root at -3. So we're going to list the roots first. So if the root is at x equals 4, it means that we must have solved the equation x minus 4 equals 0 to obtain this root. So how do we figure this out? We take 4 to the left side of the equation, so we kind of unsolve the equation, right? That means that x minus 4 is a factor of this polynomial function. Another thing we need to consider is the type of the root. So if we are told that we have a double root, it's the same thing as if saying a second order root. And a second order root comes from a factor brought to the power of 2, which means that x minus 4 must have been to the power of 2 in the polynomial equation given. The next root is at x equals -3. We are not given information about the order of the root, so we assume that the order of the root must have been 1. So again, let's unsolve this equation, bring -3 to the left side. That will make -3 a positive. X plus 3 equals 0, which means that x plus 3 is a factor. Now, in this case, we know that the power of this factor will have to be 1. We don't have to write powers of 1. But I'm just showing here just so that it reinforces our understanding of it. So therefore, we're going to say that the general form of this equation will be, let's list the factors first, x minus 4 squared x plus 3. And to make this equation even more general, we're going to throw in a coefficient a. So where a is a number, right? A numerical coefficient. Now, I am going to also emphasize the fact in here that it doesn't matter the order in which you list these factors. So you can write the equation in this format, just in case you were wondering, or you can write it in this format. So x plus 3 and then x minus 4 squared. Let's move on to the next question. So in the next question, we are told that the function is degree 4. It has an inflection point at 2, 0, and it has a first order root at x equals 5. So a lot of things going on in here. We have an even degree function. Now, if you look at the inflection point given, the coordinates are 2, 0. I want you to think, where is a point with coordinates 2, 0 located on the Cartesian plane? So this point must be on the x-axis because x equals 2, y equals 0. So which means that this must represent the x-intercept of this particular function. So the x-intercept, at the x-intercept, this function will have an inflection point. So recall what we learned in this lesson, that when we have an inflection point on the graph of a function at the x-intercept, it means that the x-intercept is order 3. And we're going to say that two things actually. So x equals 2 is the x-intercept. That will make x minus 2 equals 0, the equation where we got the root from, which means that x minus 2 must have been a factor of this polynomial function. And because is third order, then x minus 2 must have been brought to the power of 3. Next, we have a first order root, so this is more straightforward, at x equals 5. Again, let's unsolve this equation, so that means we have had x minus 5 equal to 0, which makes x minus 5 a factor. Because this is a first order root, then we're going to say that this factor must have simply been in the form x minus 5 to the power of 1. So the equation of this function must be in the form y equals x minus 5 to the power of 1 times x minus 2 to the power of 3. So when you look at the powers of 3 and 1 and you add the exponents, you see that 3 plus 1 is 4, which makes this a degree 4 polynomial equation. To make the equation more general again, what we want to do is throw in a coefficient a, right, where a is a number. Let's do one more. So in the next example, we have a function of degree 3. The roots are given at 1 over 2, 3 over 4, and negative 1. So since it is a third degree polynomial function that has 3 distinct roots, automatically we must think that each root must have been a first order root. So we're going to list the roots first. X equals negative 1. And next, we are going to get rid of the denominators. So that means that we must have had 2 multiplied by x in here, right, in order to solve for x or to isolate it. So we're going to say that must have been 2x equals 1. Again, we are unsolving an equation. Next, I want you to think first. So 4 times x. So that's 4x equals 3. Okay? And last, we have to unsolve the equation again. So take negative 1 to the left side. So x plus 1 equals 0. So right here, we have already the factor revealed. So for the next 2 roots, we have to do a little bit of work. So just one more step. So we are trying to take now the coefficient to the left side. So we have 2x minus 1 equals 0. In the next one, we have 4x minus 3 equals 0. And the last one is x plus 1 equals 0. I'm just writing it one more time so things are appear in a certain pattern here. And therefore, we're going to say that the factors are all first order, which means brought to the power of 1. And the factors are 2x minus 1, 4x minus 3, and x plus 1. And the polynomial equation will be in the form y equals 2x minus 1. Obviously, the order in which we multiply these factors won't matter. So either or. And we're going to throw in, as always, a coefficient a just to generalize the equation. We're going to move on to the next example, number 2. So next question says we have to determine the x-intercepts of this polynomial function and how many zeros will the function have when n equals 3, and explain how you know it. So our job here is to find the number of zeros. That's the only way we can figure out the number of zeros. So remember that when we say the number of zeros, it means where the y value is 0. In other words, we're trying to find the x values where y equals 0, which means that in this very equation here, we are going to have to substitute y by 0. So we're going to say 2 times x minus 4 to the power of n plus 1 must be equal to 0. So we're asked to find how many zeros will there be when the value of n is 3. So we can substitute n by 3. And we have to solve the equation. So here we go. We're going to say that to solve for x, this is where x is located. Remember, x is inside the brackets, is locked by this power, so we cannot access it very easily. So we have to take the constant term to the other side. So we have 2x minus 4 power 3 equals negative 1. Next, we have to isolate this term here so that we can get as close as possible to x. We need to access that, which means we need to divide by 2. So that means we have x minus 4 to the power of 3 equals negative 1 over 2. Next, we need to isolate the expression that contains x from this power, right? From power of 3. The way we do this is by bringing both sides of the equation to the power of 1/3. And when we do that, the two powers will multiply and will give a 1. So therefore, we will have x minus 4 equals negative 1/2 to the power of 1/3. And that would be the last step. X equals, take negative 4 to the other side, it becomes positive, and then plus negative half to the power of 1/3. And we are going to say that in this case, this polynomial function will have only one x-intercept when n equals 3. And this x-intercept will have the indicated value. If we want to double check, what we can do is we can get on Desmos and draw the graph of it. So we're going to draw the graph y equals 2x minus 4 to the power of 3 plus 1. Okay, as you can see in here, there is only one x-intercept, which is at 3.206 in decimal value, and it equals 4 plus the negative 1/2 to the power of 1/3. Remember that this will be some small negative number. I hope this made sense. Stay tuned for the rest of the homework questions. Bye for now.